Hello, my dear students. Today we are going to discuss about the numerical problem of brake. This is the numerical problem related to the differential band brake. In a winch machine, the rope supports a load W and is wound around the barrel 450 mm diameter. That means diameter of the barrel is 450 mm. A differential band brake acts on a drum of 800 mm diameter. That means the diameter of the drum is 800 mm, which is keyed to the same shaft. That means the barrel and drum both are keyed to the same shaft as the barrel. The two ends of the band are attached to a pins on opposite side of the fulcrum of the brake lever and at a distance of 25 mm and 100 mm from the fulcrum. The angle of left of the brake band is 250 degree. That means theta is equal to 250 degree. The coefficient of friction mu is equal to 0.25. What is the maximum load W which can be supported by the brake when a force of 750 Newton is applied to the lever at a distance of 3000 mm from the fulcrum. That means L is equals to 3000 and this is P is equals to 750 Newton. So now here you can see that the given data and this is the diagram of differential band brake. This is the drum and the diameter of this drum is 800 mm. This is barrel and diameter of the barrel is 450 mm and both are keyed to the same shaft. This is same shaft. And here you can see that the length L is equals to 3000 and this is 25 mm and 100 mm and this is 750 Newton which is applied at the end of the lever. Here you can see that since OA is greater than OB, here they go. This is one is OA and this is OB and OA is greater than OB. That means 100 is greater than 25. Then P will act downwards. We have already written this equation earlier when the direction of the P will depend on the value of OA and OB. So here the OA is greater than OB, that means P will act downward. If the OA is less than OB, then P will act on upward direction in this case, but OA is greater than OB, that means it will act downward. So first of all, let us consider the drum rotates in clockwise direction. So for clockwise direction, we know that the T1 upon T2 equals to e raised to power mu theta. So T1 upon T2 equals to 2.98 by substituting the value of mu and theta. Now taking moment about fulcrum O. So this is fulcrum O, then 750 into 3000, T1 into 25, direction of both the forces are same, and T2 in opposite direction, T2 into 100. So this is the equation. By this equation, we will have the value. By this equation, we will have the value of T1 and T2. And now the braking torque TB is equals to T1 minus T2 into R. So value of braking torque TB is equals to 69.6 into 10 to the power 6 Newton mm. So now torque due to the load W. This is the load W. The load W into this radius that means radius of the barrel. So we have the value of diameter of the barrel to divide by 2. So we will have the value of torque due to the load W equals to W into R. This is the radius of barrel, 225. So 225 W. So this one is 225 W mm. Since the braking torque must be equal to the torque due to the load W, That means equating both the equations TW and TB. Now the value W is equals to 309 kilonewton. After equating the equation of braking torque and torque due to the load W, we will have the value of load W. W equals to 309 kilonewton. And now consider the anti-clockwise direction, and similarly again we have to solve but we have to solve all problems, and using all the equations T1 upon T2 equals to e raised to power mu theta, TB is equals to T1 minus T2 into R, and also movement. So start we will start from T1 upon T2 equals to e raised to power mu theta. That means T1 upon T2 equals to 2.98. Now taking moment about point O for anti-clockwise rotation of the drum. This is the equation for anti-clockwise rotation of the drum. Only change T1 and T2 by changing the direction of the drum. So this now we will have the value of T1 and T2, and substitute this value of T1 and T2 in the equation braking torque TB is equals to T1 minus T2 into R. So we will have the value of braking torque TB equals to this. So similarly equating this braking torque equation with the torque load TW, the TW that is equals to 225 W. In the previous we have already discussed in the previous slide. So equating both the equation, and we will have the value of W equal to 225 kilonewton for anti-clockwise rotation of the drum. So from this we see that the maximum load W that can be supported by the brake is 309 kilonewton when the drum rotates in the clockwise direction. That means answer is 309 kilonewton. Thank you.